Okay, next we're going to bring up our own Dr. Christine Noronha. Christine's been working on Wireworm now for a number of years, since she came to PEI. And Christine has done a lot of work with a variety of rotationals, trials, as well as with some insecticides. Do you want to use this mic, Christine, and move around, or?
I might stand here, maybe, so that people can see me. Okay, so hello everyone. So as Brian has said, we've been working with wireworms for several years now, and I've been working with my colleague Bob Vernon and Todd Gabelet.
Hold the mic as close as you can, Christine.
Closer? Okay. All right. Oh, sorry. Okay. All right. So just a few pictures of the damage that we're seeing. In corn, as Ted had mentioned, we did see wireworms going right into the plant itself. As Ted, you had mentioned that you had seen them going into the plant, and so that's a cornfield here on PEI where we found these wireworm, this damage, and you can see the amount of damage here. You can see the large areas where there are no plants. So the same thing with cabbage, with the cabbage field, and as you can see, we just took this plant, this transplant, just dug it out, and you can see the number of wireworms you have here. And this is a row where there should have been plants in this row, but there are no plants because the wireworms ate them. So very high population. And here you have a barley field where we went here. The barley has grown a little bit when the barley was a little bit shorter. You can really see the damage, and here you can see patches of plants that have been eaten. And if you go and put bait traps in there, you find wireworms. So we knew there were wireworms there. So why are these wireworms so difficult to control? Bob has talked about this a bit. It's the long life cycle that they have, 4 years, right? They're soil dwelling, so we don't know where they are in the soil profile. That's what makes them so difficult. There may be, if we have found here, and I'm sure Bob has seen this too, there may be several generations in the field. So every year you have beetles coming out from here in the field. The damage occurs in the spring and the fall. So if you have any insecticide, it needs to have a very long persistence for the fall, so that you get control in the fall. But that results in a lot of registration hurdles because of the long persistence of the chemicals. And then we have here on the island all three European species that are causing a lot of damage. Now, I have found sputatter to be the main species. Shauna had talked to you about the distribution. Whenever a grower comes to me and says he's having problems, I go there, and it's always sputatter that we find there. But compounding the whole situation is that we can find all these species in the can you see that? Okay, we can find all these species in the same field. So that compounds the problem. Because whatever insecticide you use or whatever you use, it has to target all these species. So every year, Bob and I, in the spring, we discuss which chemicals we need to test. And usually Bob does a lot of the laboratory studies, and then he tells me what looks as if it looks good, and so that's what we test here. So most of we test, everything that I test has to compare to Thimet. Thimet is my standard. It has to be significantly similar to Thimet, equal to or similar or better than Thimet, because if we are going to replace that chemical, anything that replaces it has to be better than or equal to Thimet. So everything we test has to be equal to that. So that's my standard. So as you can see, I've tested several insecticides, and we test them the same way as Bob does. And we also look at, we test them for 3 or 4 years, just to make sure. At least 3 years we test the chemicals. So as you can see here, I've tested Titan 2 rates, but it has never given me very good control. But when I had kept Titan and capture together in both rates, it gave me good control, and I think it's the capture that's doing it. We had poncho, which is also clothianidin, didn't give very good reduction in damage. I had cruiser, no reduction in damage. The capture, both the high and the low rates, has given me good control. That's the bifenthrin. It's similar to Thimet. And the capture, I have used it with Admire because, as Bob had mentioned, capture on its own, if you spray capture for potato beetles, you will get control of potato beetles. But capture in furrow does not get absorbed by the plant, so you're not getting Colorado control. So I decided to use it with Admire, and we did get pretty good control even when you used it with Admire. Matador, we had 2 rates of Matador, tested it for a couple of years and didn't give me control. Force, Tefluthrin, didn't give me very good reduction in damage. We looked at Movento because several years ago Bayer came to me and told me that they are seeing Movento is actually working for them. So we looked at it here and we didn't get control. We looked at 2 rates of Movento, and we also used Movento with Titan. We didn't get anything there. Anispit and Clutch, which are liquid formulations of clothianidin, we didn't expect it to give us control, but we thought maybe. We tried it anyway. Dazitol didn't give us anything. We have some experimentals that we used. Again, no reduction in damage. This experimental one we used this year, it sort of showed some promise. So I am going to test it again next year because we got it a little bit late, so it was put in a little bit later. But anyway, it's showing some promise. So I'm going to keep testing it. But the thing is that these chemicals are experimental, so it will be a few years before you get them onto the market. It's going to take a few years, at least 7 to 10 years. I would say it's 7 to 10 years before you have them on the market. So, but this did show us some promise. So those were what we were trying. Now we did a laboratory study on click beetles, and that was with the Hort Association. They had a big study, and we did some trials with them, and we just looked at click beetle control. And what I did was I had a tub with soil in it, and we sprayed the insecticide on the soil and released the beetles in there for 7 days. And we wanted to see if they're just walking on the soil surface, if under ideal conditions, would it work? Would the chemicals work? Now, we didn't spray the beetles, we just sprayed the soil surface. And as you can see here, we had the check, we had TPA. TPA is it's a nutrient that is used by the vegetable industry. So we added that to the mix here. And we tried Success, Matador with TPA, Ambush with TPA. And then I also decided to let's try the Admire and Admire low rate and Admire high rate. As you can see, Success, this is cumulative numbers. So Success, after 7 days, I only got about 15% mortality. Matador 2 didn't give me just 15%. Now this is just walking on the surface of the soil. Ambush was a little bit better. Matador with TPA seemed a little bit better. Ambush was a little bit better. When we mixed it with TPA, it just went really low. And these were about 120 beetles that I tested it against. Admire gave us a little bit better control, the low rate. The highest mortality I got was Admire. It was 57% at the high rate. So now I didn't spray the beetles themselves, I just sprayed the soil and released them on there, and this is a lab-based study. Now, there are challenges, as Bob had mentioned, to targeting the click beetles, because they're very difficult to see. They're on the surface. You can't just walk into a field and see them lying dead there like potato beetles, okay? So they are difficult to see. They don't congregate on a plant like potato beetles, so you have to spray your entire field. And you have to use a pheromone trap in order to know when to spray and if your spray is working. Bob mentioned the same thing. You have to use a pheromone trap to see if your spray is working. You will have some beetles that are either before you start spraying or way later that come out. We are seeing them, they come out very early in the spring. So you are going to have some that come out early in the spring and they are going to lay some eggs. So there are going to be some eggs laid. But the main thing is you have to make a commitment. If you're going to spray your fields, you have to make a commitment to spray for 4 years because there's always beetles coming out. So you have to do that in order to get any control for the future. So I'll move on to another study that we did. Now, there's a lot of other studies that we did, but I'm going to move on to this one. Several years ago, we looked at brown mustard and buckwheat as rotation crops with potatoes. So, but we had these big fields. There were 1 acre blocks, and there were 3 different fields that we had these trials in, and it was replicated in each field. So we had 1 acre blocks of mustard, 4 blocks of mustard, 4 of buckwheat, and we had the barley clover, which is what your normal rotation is. So at the end of the year, at the end of the 3rd year, we planted potatoes, and then we went and we harvested the potatoes, right? And we looked at damage for the processing industry. And what did we find? The brown mustard and the buckwheat didn't really make any, there was no significant difference in total yield. The number of tubers that had no damage on them, this was important for the table stock industry because they cannot deal with any damage. So number of tubers with no damage was 16 tons per hectare and 13 tons in the buckwheat and just 2 tons in barley. And the same thing with the average number of holes per tuber. You had lower number of holes per tuber as compared to the barley if you had brown mustard or buckwheat. The tons lost also was lower. And I think several of you have already seen this table. But the tons that were marketable for processing was 45 tons and 43 tons as compared to 30 tons. So it looks like these 2 crops give you a little better control of damage and better yield. In the end, better marketable yield as compared to if you have barley underseeded to clover. So, why brown mustard? Why did I choose brown mustard and not just any mustard? It's because of the glucosinolates. But all glucosinolates are not the same. That is something, there's glucosinolates in a lot of mustards, but not all mustards have the same glucosinolates. It's this allele factor. It's this allele factor in a glucosinolate that is important. That's what makes it really toxic to insects. So you have to have this type of glucosinolates. Mustards have been looked at in great detail. There's a lot of information out there what type of glucosinolates are in each of these different mustards. But you have to find them, and brown mustard is one of them that has this allele glucosinolate. You also have the phenylethyl in its roots, which is known to be toxic to this insect. It's actually toxic to insects in general if they chew on it. And the more an insect will chew on the roots, the more this phenylethyl is actually produced. So you do have this, and they have shown that Japanese beetles, if you grow brown mustard or even buckwheat, we don't know what is in buckwheat, but if you grow these crops, they actually reduce Japanese beetle populations, and they're like the click beetles. They have a long life cycle. So, for crop rotation, so what did I use? Brown mustard, it's this specific variety of brown mustard, the Brassica gensea, and centennial variety. This is something that you can actually purchase. Centennial, there's Duchess and Centennial, okay? So buckwheat, I used a man-can variety, and we grew two crops for over 2 years. Now, what's very important is the next sentence. It's fertilizer. You have to use fertilizer. You have to make sure that your crop is healthy. If your crop is not healthy, it is not going to produce the glucosinolates to actually do anything to the insects. So you have to have the fertilizer. So in the spring, we put in the fertilizer, and we planted in early June. We planted in early June because both mustard and buckwheat are crops that like heat. If you plant it too early, it'll just sit there and the weeds will take over. Eventually the crop will grow, but it'll sit there and then you have more weeds in your field. You don't want the weeds because the wireworms will feed on your weeds. So you don't want those weeds there. So in June is a good time to plant. That's what we found. So this is what your crop should look like. Okay, this is a buckwheat crop. This is again what your crop should look like because you fertilized it and all that. So it should look like a good crop. So then in July, late July to early August, you can disc it in, and before the seeds mature, because as you all know, buckwheat and mustard can itself become a weed and give you problems. So you don't want it to become a weed. You don't want it to go to seed. So before it goes to seed, you have to disc it. The other thing about brown mustard is if you allow brown mustard to go to seed, all the glucosinolate in it goes into the seed. If you harvest the seed off, the amount of glucosinolate in your plant material is not very high. So you don't want that to happen. So you take that off. If you do decide that you want to grow it for seed, take a field where you just grow just a 5-acre, whatever acre field in some corner. Grow it for seed if you want to do that. Okay, so this is what we did. We just went in and we disked it. As you can see, we didn't mow the crop or anything. We just disked it in. And then 2 to 3 weeks later, we went and put in a second crop. Okay. Now the second crop was, and it depended on the seeder. You may need to roll it because you don't want the seed to be planted too deep in the ground. If it's planted too deep, it's not going to come up very fast. So you need to have that the seed planted at the right depth, especially the mustard seed because it's really small seed. So at this point, if you're doing this, you don't need to fertilize because there's enough fertilizer left over from your spring fertility that you put in, so you don't have to fertilize, okay? So your second crop should go in by the end of August. The reason why I'm saying this is because you want to have a crop that is, the wireworms come up in September, so you want to have a crop that is there for them, all totally grown, a nice healthy crop there in September when they start coming up to feed. And I've always found this. It's the middle of September, sometime after 15th, 16th, 17th of September, when you start to see wireworms coming up, and they are there until October, maybe first week of October. After that, you start seeing numbers decrease. And you guys have had experience with this too. If you harvest your crop early, or even if you wait like a week later, you will see the damage. So they do come up at that time, and there's a big feeding frenzy at that time. The reason why insects feed at that time is because they have to collect fat in their system to survive the winter. Potato beetles do the same thing, and if you cut a potato beetle open in the fall, you will actually see fat bodies in there. You'll actually see the orange fat in there. So they have to do that. So they eat a lot in the fall. So that's why they're coming up and there's a feeding frenzy. So in this second crop, it does not have to be disked. You can actually leave it there and it will be brown cover. It will eventually die with the cold. So here I have some examples of what happened. I had a crop. This is a buckwheat crop. You can see that it has little flowers on it. On October 18th, this is what it looked like. You have, and this is the brown mustard crop, October 18th. You see it's doing really well. This is November 6th. It's a really good crop. You can see it's got a few flowers on it. By November 6th, though, the buckwheat has gone down. The November 29th, we know we had snow this year, November 29th, or a little bit of flurries or whatever, because this is what it looked like. And as you can see, there is some buckwheat, there's stubble left, so you would have some ground cover there if you so you don't need to take it down. And here you have, so in November 29th in Harrington, you had the mustard is still green, but it's starting to go down. So, several people have asked me, can we grow this just in the fall? I'll say, I haven't really looked at this as to how many insects are there and how it affects the insects, but if you want to grow it in the fall, you can grow it in the fall, but it should be grown, you should have it planted by the end of August. That is important because you want a healthy crop in September. And if you are only growing it in the fall, following any crop that you have before, you plow it under or you disc it under, and then you go in to put your buckwheat or your mustard in, you need to fertilize, because depending on what your crop was, if it wasn't a crop that had got a lot of fertility, you have to put a little bit of fertility in. You're not putting fertility for the plant to go for a very long period of time. You're putting it enough so that it lasts until at least October. It's there when the insect is feeding. So, it does not need to be difficult, okay? Depending on the previous crop and the management practices on your land, you can either plow the field, the crop that you had over the summer, you could either plow it, you could use Roundup, you do minimum tillage, you can work it, work the field. If it had a grain crop, you all know that if you are harvesting grain, then the combine, you always have grain falling onto the surface of the soil, and that starts growing, so you need to take that out. And here I have a field which was seeded 27th of August. And what's wrong with this field? It's got a lot of barley or wheat in it. And you can see the little mustard plants, they are trying their very best to grow. The mustard plants were put in there, it was planted, but there was no fertility put down. The wheat started growing. The mustard was really like fighting to come up because it didn't have fertility. The wheat sort of took over. Eventually, when we did put fertility down there, the mustard did take over and mustard did grow. So you don't want something like this. You want to get rid of that food that's there for them that they really like. So you have to remember to fertilize your crops. So you do something to your grain. You have to either put Roundup on it, or as soon as it starts to grow, put Roundup on it, or till it, do something to it before you go in with your mustard. And then you remember to fertilize. If you are air seeding mustard, make sure that you seed it very close to the ground, because mustard seed is very small and it will actually fly all over the place. So you have to go really close to the ground and not on a very windy day. So the bottom line to all this is that you have to have a good establishment of your mustard and buckwheat crop by mid-September. You have to have that, so that when the insects go, they have one crop that they have to feed on. They will feed on the roots of this mustard. It does produce this chemical that is toxic to them, and you need to have that. Okay, so this is a field which was planted. It's a good field. It's a mustard field, really good field. But it was planted on this September 6th. By October 20th, this is what it looked like. Now, this is what it should have looked like by the end of September. But this is what it's looking like by October 20th. So it was planted kind of late. This is what it should look like. You should have a really good crop there. This is a mustard field, like it should be a nice, even, nice crop in there. And so we're trying to tweak the system a little bit more, because this is the way we had done it, and that's what I showed you. We're trying to do the fall, we're trying to study that. There's a lot more information that we need to get on this. It's not just completed this study. We have to get more information. So we're trying to tweak the system right now. And what we've done here is that crop was planted, it was mowed down, and we're allowing any seeds that had fallen. It was allowed to go to seed, but any seed that fell on the ground, on the soil surface, they're being allowed to grow. So we're going to go back in there and we're going to look at what wireworms we have and what damage we are actually getting from in this field. When next year they're going in with potatoes, so we're going to go and look at what damage we're getting from this field. So the bottom line is what I want to if you do decide to use this strategy, if you're going to go with this strategy, treat your mustard and buckwheat crop like a crop. Not just, I know you're not getting anything for this crop, but you are getting wireworm suppression. So there is going to be something in the long run. You are getting something, but you have to treat it like a crop. And unless you treat it like a crop, it's not going to work. And my colleagues here, Zenaida and Joanne here, are going to tell you more about what they did with the buckwheat and the mustard planting. So you'll get some more information from them as to what we did and how it worked. All right? Okay. You all know where I live, so you can just come in.
Anybody have a quick question for Christine on the buckwheat mustard strategy? We get way over here. We have to go over and get my exercise. If I can sneak by you here, Chris. Mr. Van Nieuwenhausen.
Thanks, Christine. One of the things I'm wondering is, I've always kind of thought that the mustard had to get chopped and incorporated, like buried in, because it's releasing gas. But is that not the case?
Yes, that is the case. When you incorporate it, and it is breaking down, and when the mustard breaks down, it actually releases the isothiocyanates, which are toxic to them. So it is releasing something there. Now, the isothiocyanate is probably not going to go very deep into the ground. So you are sort of incorporating it into the ground, and it's going to kill anything that's above that plant material that you have. So it's going to kill that, and it's going to kill any. It goes down to about 4 inches. Yeah, about 4 inches is what you would get. The isothiocyanate will move in the soil to about that depth. Is this not open?
So would it be more effective if you could actually mechanically chop it and have all the material buried? Like
yeah,
plowed in?
It would. Actually, mustard will control other diseases as well. It will control like verticillium and those kind of things as well. So if you can incorporate it, that would be really good. It might get the smaller larvae. The larger larvae probably going to move away, because as soon as they sense it, like they do with the insecticides, as soon as they sense something that they don't like, they move away, and they can move really fast, right, Bob? They move quite fast. So the larger larvae are probably going to move away. You might get some control with the smaller larvae that can move away as fast, or if the plant material is here and they are up above the plant material, so that it might get them at that point because they don't have a chance to move. They can't move down. They're hitting the plant material, so it might give them it might give you some control with that.
Okay, then my last question is, with my limited experience with fumigating, like chemical fumigation, one of the things they always stress is the importance of sealing it after to trap gas in. Is there any value to that with biofumigation?
Once again, they will move away. The larger larva will move away. You might get the small larva if you really, even if you trap it in, because I did something with the mustard meals, and mustard meals work really well. It kills all of them. In the lab, I did a study where I put mustard meal into a pot with these wireworms. They were trapped in there. It killed every single one of them. So that's the isothiocyanate that's coming out, and it kills them. But if you give the larva an opportunity to move, it will move down. So so you can seal it. You will get some control, but not like the larger larvae, the resident large larvae. You're not going to get too much control from them. Okay.
That's it?
Okay.
Okay, thanks, Christine.